What we are going to do here is open up an editor and have a look at our first Ansible playbook. So there is a lot about Ansible that I did not cover in this video, but you can have a look at the materials I have published on my website that contains information about YAML, Ansible modules, etc., etc. At that stage, we want to use it as a tool that allows us to better manage our infrastructure. We don't want to get too much in depth on how these modules work in order to provision our cloud components. So I'm going to create a new YAML file. And this YAML file is going to be our playbook. So a playbook is a collection of what we call plays. And plays are like tasks that are applied to specific hosts, specific machines. So here we are going to, because it's a YAML file, it starts with 3 dashes. And we're going to start our first play, which is going to be applied to this local host machine that is defined in our inventory. So once again, we want to run the AWS modules in Ansible on our laptop, because at the moment we don't have any EC2 instance to do anything. What we want is create the AWS components where we can run our instances. So the format for the YAML files, it's based a lot on indentation. So here, this is going to be my first item in a list. So this is going to be my first play in my playbook. It's going to apply to localhost, and then I can write down a list of tasks that I want this playbook to execute. So for each task, you usually give it a name. So the name of this task here is going to be create AWS VPC. And then a task will be linked to a module. So there are lots of modules that are available in Ansible. You can see modules are as like very advanced shell scripts that do a specific task in a very nice way. Then you can give them parameters in order to customize the way this task is being carried out. There are a few modules that you will be expected to know in Ansible, like the basic copy, file, template, etc., etc. But there are a lot of modules available, and you can find a lot of them on the official Ansible website. So I recommend and suggest that you keep the official Ansible website open, because there is a lot of information that you can find on this website, and you can build your playbooks by looking at the documentation and picking the options that fit your needs. So here, what we want to do is to create a VPC on AWS, and there is a module for that in Ansible, which is called EC2 VPC Net. So all Ansible modules, they take parameters, and our job here is going to find the correct parameters in order to configure the module and make it do what we want it to do. So you have a huge list of parameters. Usually it's a good idea to have a look at the examples down the page, because they give you some very straightforward options about creating basic tasks using this module. So here we have an example that looks pretty good. So what I'm going to do is use that example as a guide and start writing my YAML file. Switching back to my terminal, and how can I do that? Just move this window there. Okay, and here I'm back in my YAML file, and I'm going to use this amazon.aws.ec2 VPC net module. So this is the module that allows me to create VPCs on AWS. And basically you can just give it parameters. So the first parameter we are going to use is the name of the VPC. So here I'm going to use something that's slightly different from the other one. I'm going to use auto for automated. And then I'm going to go ahead and fill out all the options that are required. So you want to define a CIDR block for your VPC. So I'm going to use, let's say 10.100.0.0/16. And this VPC is going to be in region US West 2. That should actually be enough for us to create a VPC. So what we can do now is run that playbook and see if it works. So before we run the playbook, we need to make sure that we are authenticated against AWS, which means that we need to use these variables that we define in our AWS keys file. So I'm going to source this file. So now I have my end variables defined with my credentials to access AWS. And very simply, I'm just going to run my playbook against my local host machine in my inventory. So I have this local host in my inventory. And now I can just run the Ansible playbook, which is called AWS infra.yaml. And what's going to happen here is that if I've done everything right, Ansible on my laptop is going to connect to AWS, and it's going to, well, that didn't work. It's going to set up a VPC. So here it looks like I'm missing some required libraries. Okay, so this is going to be in the instructions, but I used to work with virtual environments to install my Ansible. So I didn't have the same kind of issues. You will need Boto3 and Botocore to connect to AWS services. So I already installed them, but you should run that on your computer. Once you've run that on your computer, you will be able to run your Ansible playbook, which is what I'm going to do right now. So I'm going to use Ansible playbook, AWS infra.yaml. And this time it should work. Okay, so this is the task that we wrote, where we ask Ansible to create a VPC. So we have a couple of warnings here. I'm going to look at that, but it shouldn't be a problem. What's interesting to see is that Ansible is reporting that this task changed something on the target, which is localhost, which means that something happened. And this is really interesting with Ansible, if we run the playbook again, you will see a very similar output. The big difference is that this task is going to report an OK status. This is because a lot of Ansible modules are idempotent, which means that when we run the same task once again, before doing anything, Ansible is going to check whether or not we actually need to do something. And if we don't need to do something, because in our case, the VPC is already created, then it's not going to do anything on your target. So this is also really good for idempotence. So now I can switch back to my AWS dashboard, and I can refresh my VPCs. For some reason, this is very slow. Okay, and now you see this VPC that was created through Ansible in the correct region with the CIDR that I decided to use for this VPC. So this is the first step. Obviously, we need to create much more than that because we have just created the VPC here, but we will need to create a subnet, a router, a gateway, a security group, and everything else. So this is what we're going to do now. So now we have the task in Ansible to create the VPC. So our next step is going to create the subnet. So remember that your subnet needs to be in a VPC, so you cannot create a subnet if you don't have a VPC. In Ansible, the tasks are going to be run sequentially. So they will be run from top to bottom. So if you put the VPC creation before the creation of your subnet, that means that this is always going to be the case. You will always have a VPC before you create your subnet. Now, if you look at the documentation for this subnet module, which is the one that we're going to use here, EC2 VPC subnet, we have a bunch of options once again, CIDR block, obviously, but what's really important is that we have a required argument, which is the ID of the VPC that we want to create the subnet in. So the problem or potential problem is that when we create the playbook for the very first time, we don't know the ID of the VPC. Obviously, we could have a look at the EC2 dashboard and grab the ID from there. But every time we are going to create a new VPC, its ID is going to change. So we cannot really use that as a reliable method for obtaining the ID of the VPC. Fortunately, let me switch back to my terminal. In Ansible, you have a way to obtain this information. So if I exit from my playbook, and now I'm going to, I think -v should be enough. I'm going to run my playbook using the -v flag, which is going to make it verbose. Okay, so now in the output that you see on the screen, it used to be just okay, but now we have okay, and we have a bunch of information that we can use. And this information is actually the return status. It's like a function in programming, and it's the return or the output of the Ansible module. Actually, all these information, you can find them on the Ansible module page. So for instance, here, the subnet module, you know that it will return all this information, including its own ID, for instance. So it's the same with the VPC. So you have to be able to read JSON a little bit, but here you can see that there is an ID for your VPC. So this is a little bit hard to read. So you can actually go to the doc. Look at the output return values. So you'll have a VPC object, which is going to be a complex object that contains an ID. So we should just be able to get it by using vpc.id, I guess. So what's happening here is that this output, these return values, they are available to your playbook. So in your playbook, on your task, you can say that you want to register the output of this module, and you want to register it into a variable name. So I'm going to call this AWS VPC info. And then you can use that variable in other tasks, in other places, in order to do something with the info that you got. So here I'm just going to debug. I'm going to use the debug module, and the debug module has a very useful feature where you can type in the name of a variable and it will display it on the screen. What I'm going to do as well is I'm going to make a slight change to my inventory because there is no need to gather the facts on my local host. That takes a lot of time. So I'm just going to use gather facts no on my inventory. That didn't work. Probably I missed something in the config. Okay, so we have a much better view of the output. And now you clearly see that the output, this variable AWS VPC info, it's basically a big dictionary that has a VPC key, and that VPC key has an ID entry, which actually contains the VPC ID of the VPC that we just created. So now what we can do is have a look at our playbook. And instead of debugging AWS VPC info, we're going to debug AWS VPC info.vpc. So you can go through the objects because they are dictionaries using the same notation as the Jinja template in Python. So using dots. Run this again. Okay, so now we see that the VPC dictionary contains all these things, and the one that we're interested in is this ID. So now if we go all the way down to .id and run the playbook again. Okay, so now we have the exact ID of the VPC that we have created or that we used in the previous task, and we will be able to use that ID and inject it into other modules that will need it, namely the subnet module. Okay, so let's make this happen. We are now going to create a subnet in our VPC. Make sure subnet exists, and we are going to use amazon.aws.ec2 VPC subnet. And here I'm going to look. Oops, sorry, I'm not sharing the right screen. Okay, and the subnet module takes a CIDR block. So that's going to be CIDR block, I believe. Subnet, yes. CIDR block needs to be inside the CIDR of the VPC, so I'm going to use that 0. We're going to set an AZ for our. Oh no, my bad, it's CIDR, not CIDR block. I'm going to define an AZ for our subnet. So here I'm going to use US West 2A. And what else? Well, we obviously need the VPC ID. And here there is a YAML trick. We can use the value of the AWS VPC info.vpc.id by using the curly brackets here. That it's the same syntax as a Jinja template in Python. Here it means that you want to extract the value of the variable AWS VPC info.vpc.id. The issue when using this syntax is that it starts with a curly bracket, and curly brackets in YAML are define a dictionary. So if you use this, you will have a YAML syntax error. So you need to put all of that into quotes to specify that this is going to be a string. And inside that string, you are going to replace this by the actual value of AWS VPC info.vpc.id, which is the variable that we want to use to create our subnet. So now you can run the playbook again. I disabled the fact checking in the playbook, so now it should be a little bit quicker. Requires a region. So you could use a region, or you could use an environment variable for your region. I'm going to just type in the region manually here, US West 2. Okay, so we have created our subnet. So now if you switch back to your AWS dashboard and you refresh the subnets page, you have this new subnet here that was created in the other VPC. So that's the manual subnet I created in the previous lab. And now this is the one that I created automatically. You can see that it's not really convenient because it doesn't have a name. So we're going to improve that in the playbook. So here, in order for my subnet to have a nice name, I added a tag, and this tag is the name tag. I created my AC804640 subnet here. I actually did it and I run the playbook already. So I'm just going to show on my AWS dashboard. And here you will see that I have this other subnet. So this is what I said a couple of weeks ago. In AWS, names don't really matter. You can have duplicate names here. What really matters is the ID. And here you have different IDs because these are different subnets. They belong to different VPCs. So this is the subnet that we are going to work with in our playbook. Sorry, switching back to my demo. Okay, so now we've done the VPC, the subnet. I'm not going to go too much in details, but I'm just going to show you the result for each of the modules that you need to set up. So the next one is the internet gateway. All right, so I did the internet gateway. Once again, the internet gateway actually requires a region. So what I did is that I added an end variable in my AWS keys that specifies the region so that I don't have to do it in all my Ansible modules. So here in my AWS keys, I added export AWS region equals US West 2. And I can source this file again. And now my Ansible will always work with the US West 2 region, which should fix my internet gateway problem from earlier. All right, so I've created my internet gateway. Now we need to create our route table. Okay, so I just done the route table. What's important to remember for the route table is that it uses a lot of other objects. So you'll have your subnets linked to your route table, your gateway as well with the default route, and also the VPC. So you'll need all information, VPC, gateway, and subnet, which means that you will have to have registered them in the tasks before the route table. So we're almost there. The last thing that we need to work on is our security group. So I'm going to do that now. I forgot to use a name for the gateway, so for the route table. So I'm going to fix that too. Okay, so I've completed my security group as well. This security group takes a name as a parameter, so you don't need to add a tag by itself. It needs a description, VPC ID, and here what I did is just wide open, let the traffic wide open on port 22 and 80 for SSH and HTTP access. So once you've done that, you should have a fully functional VPC in AWS with